Assalamu alaikum guys, I hope everyone having a great day and thank you so much for joining us today. So today we will talk about our app one more time. Let me show you one thing. This will automatically disappear. So you see they cannot find two dependency and they're saying me to go for settings. If I click over here, so here is all the dependencies. Okay, so let me just show you. I already showed you what is this. So here is all the file that is required to run this app, and if they cannot find any of this file, then they will suggest you to go for settings and then try install dependencies, and you don't have to worry about anything to download or install. This app will automatically download and install everything you need, and this is why this install dependency, you will see this notification wherever you open this app, as like Gromacs is actually pretty painful to install. So this will automatically download and install Gromacs if you go for dependence install settings and go for install dependency. Okay, and for now we already have Gromacs and WSL in our computer, but for now this is actually not showing because Gromacs cannot be run in Windows and I'm in Windows mode. So this is actually, if we go for Windows subsystem for Linux, then this will detect WSL and Gromacs. Let me show you. So just go for control panel over here, then go for programs, turn Windows feature on and off, then from here go at last and check this virtual machine platform and this Windows subsystem for Linux, and then okay. And after a few second or few minutes maybe, this will tell you to restart your PC, and after clicking restart, this will automatically go for Windows subsystem for Linux, and then you can use your Gromacs and WSL. First of all, you have to make a compound list, and you have to select a disease, and you have to find out a protein which you want to use for docking or a simulation. So first of all, you need the compound list, and for compound list you can go for any databases, as like here's Dr. Duke, and this is my plant. Like you have to copy the scientific name of your plant, then go for search or open Dr. Duke, just search it, and you get this list of compound. All right, so you have to download the CSV. I already downloaded the CSV and just created a folder to keep it, as like here. So in new folder we keep this list, compound list for this plant. Okay, so all you have to do is just download this compound list, and then let me show you. So here is the compound list over here. So in this column, in the chemical name column, you have all the compound over here, and there is some more column as like plant part, law parts, high parts, etc. So whatever, we get 72 compounds. First column is actually, first is a chemical name, so we have to remove that one, and so we have 72 as like a. Now you can see here is water. This is totally not draggable. So there is some more compound that is totally not draggable, as like, let me show you. Alkaloids, they actually not specifically say which alkaloids. Here is ash, that is totally not draggable also. So whatever. Now in our first module in the app, this is actually for filtering out those compound which is totally not draggable. So let me show you. You just have to, here is the name of the column. This means which column actually listed all the chemical name. You have to copy this name. You can have this name as like phytochemical name. In impact, maybe this is called phytochemical name column, and maybe other database just listed it with another name. So you just have to give this name of the column over here, then just browse. We keep the compound in downloads, new folder 3, and here is our CSV file. So we have to select this as input, and we have to just create an output folder, or we can select any folder as output folder. For now I'm actually keeping the output folder in the same folder, and let me just name it as filter. All right, so here is our output folder. Now this will, you can preview also. So now this will actually filter out all the non-draggable compound from your list. This is the basic filtration, so that you don't have to do a lots of work with other compounds. Actually if you just download the compound list from any database, they actually list some non-essential non-draggable compound also. So you have to filter out those compound, and this module actually do that with one click. Let me just run this module, and you can see this done, already done. So it is pretty fast. And also one more thing, if you want to keep any of this, they actually removing sugar and carbs, vitamins, amino acids, simple fatty acid, plant hormones, and this is actually what they're removing. And if you want to keep any of this, then just uncheck it. Okay, for now I'm just keeping check for all of this because I want to remove all of this. If you want to just keep any of this, then uncheck, and this will not remove those compounds. So this is it. So let me show you what we get. Here is the filter, and here is the kept compound. So we give a list of 73 compound, and now, not this one. So here is the list of the compound what we get. All right, in kept compound. So we give a list of 73 and now we get 48 compound over here that is actually kept, and others is not others is actually non-draggable, and this is why they remove that. Let me show you the remove folder. So this is the remove folder, and they give reason why they remove it as like plant hormone, compound class, or mixture, mineral solvent. So this is compound class, they actually not mention specifically, and this is why they remove it. A mineral or solvent, this ash is actually mineral or solvent, and this is why they remove it. Water also mineral or solvent. So you can get the reason also why they remove that compound. After this you have to just go for downloading all the smiles. So you can manually download all the smile by just copy the name over here, then go any of these databases like PubChem or any other database to paste the name as like this, and you have to go there and select the smile or copy the smile. Let me show you. Let me go for PubChem first. So you have to do this manually if you don't use this app, but in our app we can do it with only one click. Okay, so let me show you how to do it manually. So here is the compound, and here is the smile. So here is the smile. You have to copy this, and then you can paste it in another CSV file, or you can paste it over here also. So you have to do for all 48 one by one, but we don't have to do this because we have this app. And now let me show you how to do that. So just you have to browse, input this folder as input folder, m1 kept what we get from our last filter. So here we give it as input folder, and we have to select the output folder. Let me create another folder as output as like smiles, because we are going to keep all the smiles over here. And then you can check mark which database actually you want to search for. So they'll actually go for every single compound one by one, and then search for PubChem. If they can find out the compound in PubChem, then they go for the next one. So this is actually work like that. And if they cannot find in PubChem, they go for all these databases like Chamble, Cactus, Cas. So they will search all this database, and if they cannot found in any database, then they skip that. So you can select more databases as like Chem, Spider, Drug Bank, etc. So you can check mark all this. This will take a little bit time, but for now I'm actually I think enough of this 5 database actually enough for searching. And also you can activate some more settings as like if you activate this one, then this will verify if the smile is right or wrong. Okay, so suppose they actually search with the first compound and they find out that compound smile in PubChem. So they actually will go for the next one, but if you turn on this one, then they will search for the same compound in other databases like Chamble, Keg, and they check out if they match or not, if the smiles from the PubChem and the smiles from Chamble is actually matching for the same compound or not. If they actually not match, then they show some conflict in another CSV folder. But for now I'm actually keeping this off, and here you can preview which actually you give as input folder. So let me just run this module. This will take a little bit time. If you just turn on this one, this will take a little bit more time actually. So for now I'm just keeping this off. Also you can just select how many tries you want. So this will try 3 times over here, and after that if they cannot found, then they actually skip that compound. So let me run this module, and we will see you after this actually finish. Let me show you first. So they search for the first compound, and they actually found it in PubChem. I already showed you this compound actually found in PubChem. So they get the smile from PubChem, and here is the second compound. Let me show you. If I search for the second compound in PubChem manually, then you can see here is the second compound, and here is the smile. Here is the smiles. Okay, so they will do this for every single compound one by one, every single 48 compound, 47 actually. All right, they cannot find this compound, the number 3 actually, out of 47 they cannot find the number 3 compound. Let me search it in PubChem, and let me show you if we can find manually or not. So see, there is no compound with this name listed in PubChem, but in some literature, one literature actually, one research paper, they listed this compound. So they listed this compound in research paper, but not in this database. Also they cannot find in Chamble or any other database. So I just show you in PubChem. You can search with the name in Chamble or any other database, zinc, CAG, Cas, and I think you cannot find that. And here is the number 5 compound that is found in PubChem. They cannot find the number 4 compound also in any of this database what I selected. Number 6 compound also not found. So they're searching for all these 5 database, and they actually cannot find it, and this is why they're skipping that. And I don't know why they actually removing that, because I see what actually not found in any of the database as like this compound. They are actually mentioned in some research paper, and this compound actually researched for a long time, as like I see a lots of research paper with some of this not found compound, and some of them actually using for medicine also, and this is why maybe they actually not listed those in databases, because they're actually using for medicine commercially, and this is why they remove that compound from the database. Also, if they cannot find it in any of this database, they try to create the smile with opsin, or they just try to search for the IUPAC name or synonym name and then try to create the smile with opsin. If they fail, then they just list it as not found. So you can see we done our smile feature. They found 23 compounds and they actually not found 24 compound, and this is because we just take a complicated plant, and those actually have a lots of compound that actually used for medicine, and this is why those compound actually not listed in any of this database. They remove all this from the database, and this is why they cannot find 24 compound. Okay, so let me show you what data we get over here. So here is our smile. For this is actually all the smiles that is found, and in the middle you can see not found, not found, this not found, this not found, this not found. So you can see some of this actually not found. Also, they give the confidence level as like 70% confident that this compound smile is this one. Okay, so if you see below 50% confidence, then you can actually just search it manually to just verify, or you can use this option to verify. I already showed you, you can use this option to verify, and if you use this option to verify, then you can see we have another file, CSV file. Here is the conflict file, and if they actually find some conflict in different databases, like they search the same compound in different database, but they actually cannot match the smile from both of this database, then they actually show you over here the first source smile, first smile over here, second smile is over here, second smile over here, second source, first source may be Papkian, second source may be Chamble or any other database, then they will show you the smile and what is the difference. Okay, so if you use that option, that will be better, but it will take a little bit time, actually extra time, to just verify or just check out. All right, so module 2 is done. Our smile, we get a list of smile, then you have to go for admit, or you have to do the admit to just take out some non-draggable compound, more non-draggable compound over here. So you just have to come over here and copy all these smiles like this. Then you can go Swiss Academy to do admit manually, or also you can do with my app. You can use RDKit. Let me open the module 3. So here is offline RDKit. This is actually fast and you don't need any website for that. This will automatically do. You just have to give the input folder as like this, M2 smiles, and it will automatically do all the admit. But I don't recommend this because you can find a lots of mistake over here. RDKit is actually not dependable. You can do with Swiss Academy manually, as like I'm doing now. So you have to do just copy all this and then come over here in Swiss Academy, paste all this, and in the top you see this name smiles. I don't need that, so just delete that and then run, and this will do one by one all this smile side event, and here is it running. So you can see one by one doing every single of this, and after it's done you can download the CSV file over here. Okay, so let me just wait to complete over here. So 18 done, 21, 22 and 23. So it's done. Okay, now I will download the CSV file, and I will keep the CSV file over here. So here is our Swiss Academy, and now we have to filter with admit, with our admit result. So I selected this one. Now I have to give the input file as like what I downloaded just now, Swiss Academy, and have to just create another output folder as like. So here is the output folder. Also you can change all this value according to your need. If you understand this value, then you can change it manually, and whatever you need actually you can change it, as like if you just want to keep all the molecule over 800 weight, molecular weight over 800, then you can increase this. If you want less weight, then you can decrease this, and they will accept all the compound under 500, and if they exist after over 500, then they actually just keep it under review, as like they can be draggable, but also they cannot be draggable, and this is why they will stay under review. And if this go over 800, then they automatically will reject that compound. So I already selected the input folder and output folder, and let me run. So admit filter is also done. Let me show you. So here is the admit, and here you get 3 files: accepted, reviewed and rejected. Accepted is actually under 500 and under all this condition. This is accepted file. Reviewed file is actually this, all this 800 molecular, log p 6.5, log p rejected, 2 below 2 tpsa is reject above 200. So whatever follow these rules, then they actually in reviewed folder, and whatever actually didn't follow any of this rule, then they actually get rejected. So let me show you all the three folder. So first one is actually accepted. This is not a big problem. So we get three accepted compound, and let me check out the rejected folder. So we get 15 rejected compound. All right, and why they get rejected, let me show you. So here is the hard reason why they get rejected. This is two polar, log p is below 2, extreme physiochemical properties, and this is why they get rejected. And toxic offers, they are very toxic. And the soft reason is actually single pains alert, they actually break the pains rules, and some more other you can check out why they get rejected. Let me show you the review folder, review file actually. So here is the review file, we get 4 reviewed file. So why they is under review, let me show you. The final decision is under review, and why this is because possible drug-like compound requires structural optimization. So you can use this or you can make this druggable after doing some optimization in their structure and any other, okay, whatever. So this is all three compound you get, and you have to download. If you want to go for docking, then you have to download all the accepted compound, as like you have to go, just copy this smile and then go for pubchem and just search with the smile, and you will get the, let me show you manually. So just go for pubchem, search with the smile, and go for this compound and download their CSV, not CSV actually, SDF or any other format. So this doing manually, all this actually take a little bit time, so you just can do it with one click in our app. And for now we have only 3 compound, so this is pretty easy. But whenever you get over 50 or 100, then this will take a long time to do it manually one by one. But with our app you can do it with only one click. So just go for 3D structure downloader. Here you can just select the CSV file. For now I'm using the accepted. I also use the reviewed. We don't use the rejected folder, so rejected CSV actually, so I'm for accepted. Here we get give the input folder, then let me just select the output folder as like accepted. So we will use this as output, and then we can actually give some more rules over here. You can check out, you can read, and you can understand what they're actually saying. So for now I'm just going for, you can preview also which file you give, and let me run the module, and this will automatically download all the 3D structure from different database. If they cannot find in pubchem 3D, then they will try some other database also. So they're finding all this in pubchem 3D, so they don't have to go for other database there. All right, let me show you what we get. Here is the accepted, and here is all the 4 compound and their 3D structure. Let me open maybe this 3, because last 2 is actually pretty similar. So here is the 3D structure, and for another one here is the 3D structure, and the other one is over here, the 3D structure. So this is all 3 accepted compound. All right, so you can do this by one click with this module for 3D structure. And after doing this, you have to go for docking, and you can do docking with our software also. You just have to select the protein what you already prepared. I already show you how to prepare your protein in our video, so you can check out that. So let me just show you how to do docking with our software. So here is the protein, clean prepared protein, and 1T49. Then you have to just set up the grid box. Here is the grid box. You can set up the grid box according to the reference ligand, as like if whenever you download the protein, you can see 1 or 2 reference ligand is actually there. If you have that, you can use that. For now in 1T49 we get a reference ligand, we already saved that. Let me show you. So we already saved that in, not here, here is the ligand, and here we saved the reference ligand, maybe not here. Okay, here is natural ligand from protein. So here is the reference ligand. So you see this is the reference ligand when I downloaded the structure. So you can use this, and you can just set up the box over this area only. Also you can do blind docking. You can just remove that ligand, or you cannot, you just have to remove that ligand to just do blind docking, as like just don't use any parameter over here. Center box on protein. So here is the center box on protein, and here is the center box on reference ligand. So if you center box on protein, this will be blind docking, and if you center box around ligand, then this will be the docking, this will be the specific docking. Okay, and after that you have to select the ligand folder. as like we downloaded all the ligand in our accepted folder, admit, and here is the accepted folder where all the ligand is actually downloaded. So let me select this folder. I have to select another output folder as like accepted doc. Okay, oh, okay, give me another name actually, accepted doc with app. Okay, so this docking is done by app, and also we do docking with Pyrex or any other software and try to combine if my app is actually giving the correct result or not. So let me run this docking. So it's running. We already done docking with other software, and I will try to show you the data, and we'll try to show you the matching data actually. So 1 done, 2 done, 3 done, and number 4 is actually running. So number 4 is running, and it's done. Okay, so for number 1 we get minus 7.68 kilocalorie per mole binding affinity. That is the best. You can see over here. Also you can get all the results over here. So here is the docking results. Docking failures is actually for if your docking is failed, then this will go under docking failure, but none of our docking actually failed. So here you can see molecule 1. This is pose number 1. You get 9 posts for every single of this, and all of this actually named after this as like PubChem CID, the compound name and the molecule number. So here you can see the lower RMSD and upper RMSD. Also you get the complex. So here is the complexes. Here is all the 9 post complex. So first one is actually minus 7.68 or 7.89, the best among all those poses. So let me open this, and here you can see the complex. Also you can see in Discovery Studio to check out all the bindings. So let me show you. Here I open Discovery Studio, and we will open the first compound over here. So here is the complex, and here is the ligand. So if I go for ligand interaction, here it's show me all the binds, as like we can see 3 hydrogen bond over here. Also if I can see it on 2D diagram, so here it is. So 3 hydrogen bond, 1 pi sulfur bond, and Y pi donor hydrogen bond. Here is the pi donor hydrogen bond. Okay, so I think you understand, and here is all the poses, all the 9 poses. So for molecule 1, here is all the 9 poses from 1 to 9. Here is molecule 2 from 1 to 9, molecule 3 over here. All right, so I hope you understand, and now let me show you. Here is only the poses. Okay, this only show the pose. This actually on the right coordinate, you can drop your protein over here and you get the complex. Okay, you can use this also. So just you have to drop the protein over here and you get the complex. So this only showed which coordinate actually the ligand actually present. All right, whatever. So let me just match this result with a manual docking with Pyrex. I already did that. Let me show you. I already did that over here. Admit filter, dock with Pyrex. So docking with Pyrex, here is the result. You can download the best pose from Pyrex also. Here is the result. So let me combine the result with my app. So this is my app result, and this is the result from Pyrex. Give me a moment. I want to just keep it side by side. Upper RMSD, lower RMSD. Okay, so this is actually side by side now. So for pose 1, for molecule 1, there is this result is actually from Pyrex, this one. So for molecule 1, you can see 7.8, the best pose, and in our app we get 7.89 for the best pose. 11482900 So the docking energy is actually minus 7.89 for my app, and docking energy is minus 7.8 for from Pyrex. Okay, and for 18512400, okay, this column. So here is 185124, this column, and here is 00. All right, so let me find out 185124 over here, 18512400. So you can see this one give me minus 7.66 and this one give me minus 7.5. So this is actually pretty close, not that much difference. And for 68857, here is 68857 over here, this one 00, and here is 68857 RMSD 00 is actually minus 7.68, and for this one minus 7.9. So pretty close, and I don't think so this will affect that much, because after that you will do molecular dynamic simulation, and there you can see also you can check out the bindings or the interaction with Discovery Studio. So I don't think so this little difference will make any problem or something. Our module 1 to 5, and this is everything what I show our app can do. Also you can do 1 to 4 with one click only. Let me show that. You just have to, here is the dashboard. So you just have to give, let me reopen this to show that. You can do module 1 to 4 with one click only. So enter the app. They actually not having this file because I'm in Windows mode, and this is why suggesting to download, but I already have that. If you don't have any of this, they will show you this notification, and you can click on install Gromacs in WSL, and it will install everything, and you don't have to do anything. So here is run all 1 to 4. So if I just select a input folder as like plant chemical, and select the output folder as like a new folder in folder number 3, then if I go for running module 1 to 4, then this will automatically do all the module. So here you can see this running all the module one by one, and you don't have to do anything else. You just have to select the chemical compound list, and then all of this actually automatically done one by one. And after that you can go for docking, and after that you can go for molecular dynamics simulation, and you can get all the result in post MD analysis. So this is it for today. See you on the next one, guys. Bye bye for today.